Army aviation personnel are familiar in a general way with the Chinook helicopter. Its twin-turbine engines, tandem overlapping rotor configuration, and quadricycle landing gear are distinctive features. In this film, we will examine the Chinook and become familiar with its design and its systems. The Chinook has clean lines and efficient design for its mission, the transportation of troops and cargo. Engines, transmissions, and drive shafts are located on top of the fuselage, with no obstruction of the cargo compartment. For comparison, the Chinook is 1.5 feet shorter than the Shawnee, but its cargo compartment is 10 feet longer than the Shawnee's. The rear ramp and door open and close hydraulically. They are controlled by a lever at the right rear of the helicopter. Without engines operating, pressure from a hydraulic accumulator actuates the ramp. If the accumulator has insufficient stored pressure, this hand pump can be operated to increase pressure to operate the ramp as well as other hydraulic components, which we will see later. The Chinook may be flown with the ramp partially or fully open to accommodate extra long cargo. Provisions are made to carry cargo too bulky for the compartment. An 8-ton capacity cargo hook for external loads is provided. The lower rescue door is unlatched. It is opened manually with a crank which moves it down and aft to lie parallel to the fuselage when fully open. When the retainer straps are released, the hook swings down into operating position. The ends of the beam are trunnion mounted to the fuselage so that the load can sway fore and aft without inducing pitching movements in the aircraft. The hook is roller mounted on a curved beam so that side-to-side swaying of a sling load does not tend to make the helicopter roll. The load is normally released hydraulically. As an aid in the loading or unloading of cargo, a hydraulic-powered winch is provided in the forward end of the cargo compartment. The winch is equipped with 150 feet of steel cable and a high and low-range gear shift. The cable can be rigged through overhead pulleys to hoist personnel or cargo through the hatchway. Moving now to the exterior of the Chinook, we will observe some of its service and maintenance features. Fuel tanks are contained in pods on each side of the aircraft. Ease of maintenance was one of the chief design considerations in the Chinook. For example, the landing gear components are readily accessible through access panels, and right and left landing gear components are interchangeable with minor modifications. All of the Chinook's access panels are hinged to the fuselage. They cannot be dropped or blown away while maintenance is being performed. For use during ground operations, 2 external interphone receptacles are provided, one near the entrance door. The other, also on the right side, is at the aft end of the aircraft. Steps are provided at the forward and aft ends of the aircraft on the right side. Work stands and ladders are not required. Platforms are built in wherever they are needed. All regular maintenance jobs can be performed with tools from the standard mechanic's toolbox. A walkway with no-slip surfacing runs down the length of the helicopter. Parallel with the walkway is a tunnel, shown here with covers removed, through which the drive shaft to the forward transmission runs. The tunnel also carries hydraulic lines, electrical wiring, and control linkage. With these items accessible from the exterior, inspection and maintenance can be performed even with the Chinook fully loaded. There are no components requiring periodic inspection under the cargo compartment floor or within its walls. A grease gun is practically unnecessary on the Chinook. Bearings on the rotor head assembly are all oil lubricated. Each oil reservoir has a sight gauge for checking the lubricant level. The control rod ends and bell cranks are dry lubricated and require no greasing. The Chinook has been referred to as an hydraulic helicopter. Its hydraulic systems contain an unusual amount of plumbing. The Chinook has 3 completely separate hydraulic systems, referred to as Flight Control System number 1 and number 2, and the Utility Hydraulic System. These 3 systems are completely separate. Each has its own fluid reservoir, plumbing, and pump, driven by the accessory gearbox on the aft transmission. The 2 flight control systems do identical jobs, and the Chinook can be flown with only one of the 2 systems operating. The flight control systems provide hydraulic power to operate the stick boost actuators, the stability augmentation system extensible links, and the upper boost actuators. The stick boost actuators are situated in a lower flight control compartment just aft of the co-pilot's seat. These hydraulic actuators are operated by movement of a system of push-pull rods and bell cranks which run under the floor to the cockpit flight controls. They supply hydraulic assist for the cockpit flight controls. The stability augmentation system extensible links are the muscles of a system you will hear referred to simply as the SAS. The SAS links are located just above the stick boost actuators. They automatically make corrective movements of the flight controls to compensate for minor variations in pitch, roll, and yaw. As muscles, they receive their orders from a gyroelectronic brain which senses and corrects for these minor deviations. The upper boost actuators are also referred to as pivoting and swiveling actuators. They are connected between the swash plates and the structure of the aircraft. Their extension or retraction moves the swash plate to control the flight of the helicopter. The boost actuators are controlled by valves, which are operated by rods running to the flight control mixing unit. This unit receives thrust, pitch, roll, and yaw movements from the lower controls and converts these 4 movements into 2 integrated movements for the swash plates. These rods run aft to similar upper boost actuators on the aft swash plate. We can see that the Chinook's flight control system is completely dependent on hydraulic power. It is a fail-safe system, however, since the controls operate efficiently with only one of the 2 hydraulic systems operating. The utility hydraulic system consists of a hydraulic power and engine starting system and 5 subsystems. The ramp actuating system, the rotor brake and aft wheel swivel lock and brake system, the hoist system, the cargo hook release system, and the forward wheel brake system. All 5 subsystems are powered by one pump in the hydraulic power and engine starting system. This system is unique in Army aircraft. To describe it, we will start with the hydraulic accumulator we saw earlier. If pressure is low in the accumulator, it can be recharged with the hand pump. In a diagram, it looks like this. When a valve is opened, pressure flows to the APP motor pump. APP is the abbreviation for the auxiliary power plant, which we shall see in a moment. The APP motor pump is a dual function device. It serves as a motor to start the APP. Then, after the APP is operating, it serves as a pump to provide hydraulic pressure. Therefore, the APP motor pump drives the APP engine to start it, then is driven by the APP to serve as a hydraulic pump. With the APP started, pressure flows to an accessory drive motor. This motor, in turn, drives the accessory gearbox. With the accessory drive motor operating, the accessory gearbox and all of the Chinook's hydraulic and electrical systems can be operated without starting the main engines. The utility system pump, the two flight control system pumps, and the electrical system's two alternators are all driven by the accessory gearbox. With the accessory gearbox driving the utility system pump, the 5 utility subsystems are pressurized. The same pressure from the utility system pump is used in the main engine starters. These starters are hydraulic motors, which crank the engines up to starting speed. With the engines operating, power flows to the aft transmission, which then takes over the job of driving the accessory gearbox. Before we move on, let's review the hydraulic power and engine starting system. To provide hydraulic and electrical power, the accessory gearbox must operate. This can be accomplished in 2 ways. Stored hydraulic pressure in the accumulator can be used to drive the APP motor pump. Acting as a motor, it starts the APP engine. Now the APP motor pump functions as a pump to drive the accessory drive motor, which operates the accessory gearbox. With the accessory gearbox functioning, all of the utility subsystems, as well as the flight control hydraulic system and electrical system, can be operated for ground checks or maintenance. To start the main engines, the same procedure is used to obtain utility system pressure. This pressure is then diverted to the hydraulic engine starters, which start the main engines. The engines now provide hydraulic and electrical power by driving the aft transmission and accessory gearbox. The Chinook's hydraulic engine starting has one important advantage. The aircraft is truly independent in the field. External electrical power is rarely required. The Chinook's battery is small, since it is used only to provide starting ignition. The utility hydraulic system's 5 subsystems do not differ very much from similar systems found on other Army aircraft. The ramp actuating system's operation was described earlier in the film. The rotor brake, the aft wheel swivel lock, and the brake system consist of 3 separate hydraulic circuits. One circuit passes through an accumulator and rotor brake control valve to the rotor brake. Pressure stored in the accumulator assures that the rotor brake will function even with the utility system depressurized. Another hydraulic circuit runs to the swivel lock control valve and onto the left and right swivel locks. These locks retain the aft wheels in a trailing position. The third hydraulic circuit goes to the aft brake control valve and then to the left and right aft wheel brakes. The aft brakes are parking brakes. They are not maneuvering brakes and do not function when the pedals are depressed. The Chinook's forward wheel brake system does not differ from the maneuvering brakes on other aircraft. The pedals are operated conventionally and operate the front wheel brakes. The hydraulic hoist system circuit includes a hydraulic motor to drive the winch and a hoist control valve to control its speed and direction. A simple circuit also operates the cargo hook release system. The hydraulic hook release valve is normally operated electrically by the pilot, co-pilot, or crew chief. In the event of malfunction of the normal system, the hook can be released manually by the crew chief or from the cockpit by blowing it open with compressed air, which is stored in a chamber inside the hook. The Chinook is the first Army helicopter with a dual alternating current electrical system. The two alternators each supply 208 volts of three-phase, 400-cycle current to two separate circuits. If one alternator fails, the other automatically supplies the entire load. For components requiring direct current, dual transformer rectifiers are situated in the forward end of the left pod. A nickel-cadmium 24-volt battery is located in the same compartment. It supplies emergency DC power and starting ignition for the APP. The Chinook's AC system delivers more watts of power per pound of system weight than a DC system. Let's take a moment to learn the functions of three systems which help the pilot to fly the Chinook. The Stability Augmentation System, or SAS, promotes stability by reducing the effects of turbulence. When the Chinook pitches, rolls, or yaws, the SAS immediately feeds in corrective control movements. SAS relieves the pilot from making constant minor adjustments for variations in pitch, roll, and yaw. The Differential Collective Pitch Speed Trim System, or DCP, provides a positive cyclic stick position at high rates of speed. It also corrects for the abrupt changes in speed caused by gusty winds. If flight airspeed is constant and the Chinook is temporarily displaced longitudinally by gusty winds, the system will automatically return the helicopter to its original airspeed. The longitudinal cyclic speed trim system increases the efficiency of the Chinook at high speeds. Normally, when a helicopter increases its speed, it assumes a nose-low attitude. The longitudinal cyclic speed trim system overcomes this in the Chinook. When the Chinook's speed is increased, the longitudinal cyclic speed trim system tilts the rotor discs so that the fuselage remains nearly level, thereby reducing fuselage drag. In the cockpit, there is a change we should note. The control which adjusts collective pitch is called a thrust rod. To move the thrust rod, this trigger must be depressed to release a magnetic brake which normally locks the thrust rod in position. The magnetic brake can be forced or broken in the event of a jam. When making collective pitch changes, it is not necessary to simultaneously twist the grip to adjust power output. Power is automatically adjusted as collective pitch is changed. In addition to the standard instrument panel configuration, the Chinook is equipped with electrically anti-iced and defogged windshields. Electrical current passing through a conductive film between two sheets of glass heats the windshield to remove ice or fog. The Chinook is a complex but rugged aircraft. All of its components are designed for long and trouble-free life. Let us review some of its unique systems. Its loading ramp provides easy access to the large cargo compartment equipped with a hydraulic winch which can pull cargo into the helicopter through the ramp opening or through a hatchway in the cargo compartment floor. An 8-ton capacity hook is provided for sling load operation. Ease of servicing and maintenance were prime considerations in designing the Chinook. Work stands and ladders are not needed. All panels are hinged in place. All regular maintenance can be performed with tools from the standard mechanic's toolbox. The drive shaft, hydraulic lines, electrical cables, and control rods run through an easily accessible tunnel at the top of the aircraft. The Chinook uses hydraulic power to perform many functions. It has 2 complete flight control hydraulic systems which normally operate simultaneously. Either system can carry the full load, however, if the other fails. The utility hydraulic system consists of a hydraulic power and engine starting system and 5 subsystems. Dual alternators provide alternating current for most electrical equipment. Dual transformer rectifiers and a battery supply electricity to units requiring direct current. 3 electro-hydraulic systems aid the pilot by increasing stability in turbulence, compensating for gusty winds and maintaining a level attitude at high airspeeds. In the cockpit, there are a number of features which are new in Army aircraft. Every unique feature incorporated in the Chinook is designed to make it more effective in its mission, the transportation of troops and cargo. In the field, the Chinook fills an important position in the Army's progress toward air mobility. Its large payload, both in weight and bulk capacity, greatly exceeds the capability of any helicopter in its class. With the Chinook, we have come a long way toward reaching the ultimate in rotary wing design.